This is PreCalculus 12, Chapter 8.3. We're going to be looking at permutations involving identical objects. So, for instance, how many ways can Canada be arranged? Well, we have three A's here. They're all identical. It doesn't matter which order we put them in. So we could say CA1, NA2, DA3. This is the same as CA2, NA1, DA3, and that's the same as CA3, NA2, DA1. Okay, so I think you get the idea. There's 3 factorial ways to arrange A1, A2, A3, but A's are identical. So eliminate 3 factorial ways. Okay, and that means we divide. So we do the permutation as before, 6 factorial, and we just divide by 3 factorial. 6 times 5 times 4. We do 20 times 6, that's 120 ways. Let's look at something a little bit harder. How many ways can Mississauga be arranged? We have 1, 2, 2 I's, 1, 2, 3, 4 S's, 1, 2 A's. So we just do 11 factorial over 4 factorial times 2 factorial times 2 factorial. It's a little bit big to do in my head, so doing it on the calculator, we got 415,800. And again, we are eliminating identical ways. And it doesn't have to just be letters, it could be digits. How many ways can we arrange 1, 2, 2, 2, 5, 6, 6? So there's 1, 2, 3, 4, 5, 6, 7 digits. We have 1, 2, 3 digits and 1, 2 digits. So 3 factorial, 2 factorial. And we do it on our calculator and we get 420 ways. And how many ways can 444, 444 be arranged? Well, we have 6 digits, but it's repeated 6 times. This is 1. Let's look at something harder. A 34-term series consists of -4 and +13. How many ways can they be arranged to a sum of 0? Let's ignore this for now. We note that 4 and 13 are relatively prime. So it takes 13 times 4 minus 4 times 13 equals 0. Okay, they have no common factors, is what relatively prime means. So we actually need to multiply by each other in order for them to cancel out. Or 17 terms, because we have 13 terms of 4 and 4 terms of 13 to make 0. And because we have 17 terms, we still need another 17 terms to make 34 terms. So we need to repeat 2 times to get 34 terms. Now we go here. For problems that aren't written as letters or digits, we can use them in place of objects to conceptualize for easier solution. Okay, so use f equals -4 and t equals 13. So we permute. We don't have room to write all of this, but I'll show you the idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 fours and 4 13s. And dot, 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 we repeat. So we have 34 objects. We're repeating the 4 13 times 2, so that's 26. And we're repeating the 13 2 times 4, that's 8. And if we do this on the calculator, we get 1856204. Okay, let's take a look at something a little bit more difficult. How many ways can Seabiscuit be arranged keeping the vowels together? So again, we're doing an arrangement of an arrangement. But we have repeats. So we have 5 vowels. 1, 2, 3, 4, 5. And we have 5 consonants. 1, 2, 3, 4, 5. So we're going to treat the vowels as one letter. So we have S, B, S, C, T. Those are our consonants. And we have the vowels. So that's 6 factorial. And we have 1, 2 repeats. And then we need the fundamental counting principle because we need to arrange the vowels. So these are our letters. And now we're going to do vowels. So we have 5 vowels. That's 5 factorial. And we are repeating just I. A, E, and U are singletons. So that's 2 factorial. And we do this on our calculator. We get 720 over 2. We get 120 over 2. We can actually do 120 divided by 4, so that's 720. 120 divided by 4 is 30. And that's not too difficult to do. This is 216 ways. Okay, so that's an arrangement of an arrangement. So we are doing a special case of identical objects. We have to use up all the letters. If we use fewer letters to make up our words, there is no set formula that works. Some formulas work part of the time, but they don't work all of the time, so it's best not to try it. Let's look at a backwards problem. A word contains 5 letters and has 20 arrangements. Okay, so that's 5 factorial over x. And it has 20 arrangements. So x equals 5 factorial over 20. We cross multiply, and this is 120 divided by 20, and that's equal to 6. There's only one way to get 6 using factorials. Remember, this needs to be factorials. We are dividing by factorials. And the only way to get 6 is 3 factorial. There's no way we can make 2 factorial by some other factorial because there's no factorial that equals 3. So we have a word. We need a word that contains 5 letters with 3 repeats. And looking at my farm, geese comes to mind. Now, if we have x equals 24, this could be 4 factorial because 4 factorial is 24. But 24 is also 3 factorial times 2 factorial times 2 factorial because this is 6 times 2 times 2. That's 6 times 4. That's 24. If we had x equals 6, we just saw that 3 is the only way to do it. Also, x equals 12 is not ambiguous. So 12 is 3 factorial to get 6, and then we need just 2. That's 2 factorial. And that's the only way to get 12. So don't just use formulas. Take time to consider if it is fundamental counting principle, arrangements, or arrangements of arrangements, or arrangements with duplicate objects. And duplicate just means identical. And that completes this lesson.